This mini-chatbot answers in your browser. No neural network, no GPU, no cloud server, just matrix math, and it still understands you. The same mathematical core powers ChatGPT, Google's search, and the equation Schrödinger used in 1926 to compute the hydrogen atom. Three massively different systems, one mathematical idea at the heart of all of them: eigenvalues. Buckle up. Imagine you want to predict tomorrow's stock price. You have the last 5 days: 100, 102, 98, 105, 103. What comes next? You draw a line through the points that minimizes the error. That's regression. Now replace stock price with word. Replace the last 5 days with the last 5 words. Same problem. ChatGPT is, at its core, a forecasting model. Incredibly good, incredibly large, but a forecasting model. Wait, stop. ChatGPT has 175 billion parameters, trained on half the internet, billions of dollars in GPU costs, but the mathematics behind it, the question. Find weights that minimize prediction error. That can be answered with just 505 words, and in a way where you understand every single detail. Linear regression. Find the line that minimizes the distance to the data points. Here are 5 data points. The orange line minimizes the sum of all errors. Mathematically, this leads to this formula. C hat equals X transpose X inverse times X transpose Y. X transpose X. That's a matrix, and this matrix has eigenvalues. And now comes the crucial moment. A matrix is a machine. Vector in, vector out. Most vectors get both rotated and stretched, but some vectors are special. Their direction stays the same. Only the length changes. Such a vector is called an eigenvector, and the factor it's scaled by is the eigenvalue. Eigenvectors are the natural axes of a matrix. Eigenvalues tell you how strongly it stretches in each direction. What happens when you apply a matrix over and over again? Lambda equals 0.5. After 10 steps, only 0.001 remains. That direction vanishes. Lambda equals 1.5. After 10 steps, 57. That direction dominates everything. The largest eigenvalue always wins. That's PageRank. That's why Google works. The dominant eigenvector of a massive link matrix determines the ranking of every web page on the internet. But there's a problem. If your model is too flexible, it memorizes noise. It fits the training data perfectly, but is useless for new data. Small eigenvalues correspond to noise, large ones to signal. If you don't tame the small eigenvalues, your model learns randomness. The solution? Regression. You add lambda times the identity matrix. Lambda is the break. The larger lambda, the more you ignore noise. The result? A smooth, honest prediction instead of wild curves. Linear regression can only fit lines. But what if the data lies on a circle? No line in the world separates inside from outside. Language is not linear. How do you turn a line into a curve? The idea: project the data into a higher dimension where a straight line is enough. Here on the left, not separable. Through a transformation phi, they become separable. But you never actually compute in the high dimension. You only use the similarity between data points. That's the kernel function. And here's the remarkable part. It's been proven that a Gaussian kernel can approximate any smooth function, just like a neural network. But computing a kernel directly is expensive. N-squared entries. Random Fourier features solve this. A single cosine transformation approximates the entire kernel. 1,024 features in cosine, 1,536 kernel dimensions out. And after that, everything is linear again. Z transpose times W gives a score for every word in the vocabulary. The nonlinearity lives in that one cosine step. Everything else is a single matrix multiplication. And now the result. The concrete path of a word. 5 context words go in. Encode. Each word is hashed and position-weighted. 1024 dimensions. Random Fourier features. A cosine transformation. 1536 dimensions. Z times W. A matrix multiplication. 505 scores, 1 per word. Argmax. The word with the highest score wins. 3 functions. 120 lines of JavaScript. The entire language model. The numbers. ChatGPT. 175 billion parameters. Trained on half the internet. Thousands of GPUs over months. KRR-Chat. 780,000 parameters. 104 training sentences. Trained in seconds. Runs in your browser. Wait, stop. How do we know it actually works? That it hasn't just memorized everything? Every single word in the response is color-coded. Cyan. This sentence was retrieved via keyword search from the corpus. No KRR needed. Pure text search. Green. The model predicted this word, but the word sequence exists in the training data. Memorization. And now orange. The model predicted this word, and the word sequence does not exist in the training data. That's generalization. The model generated something it has never seen. It interpolates in kernel space between learned examples. 20 to 40% of words are orange. ChatGPT generalizes brilliantly, but you don't know why. The KRR chat generalizes more modestly, but you can see the reason behind every single word. Same core idea. Find weights that minimize prediction error. Controlled by eigenvalues. Stabilized by regularization. Extended by kernels. The same glass bead game, different scale. The full blog post with interactive visualizations is on KI-Mathias.de, and you can try the KRR chat yourself, right in your browser, link in the description.